Hi, it's Charlie Curtis here. I don't think I'm going to be able to join you on Thursday, so I wanted to make a quick video just to get some thoughts down and to share them. Um, mostly on carbon dioxide removal and a bit on systems change at the end. So just starting with this analogy of thinking of the atmosphere as a bath. So we've been pouring carbon dioxide into the atmosphere since the Industrial Revolution, when it was about 280 parts per million. It's now 414 parts per million, and we're still pouring lots of carbon dioxide into it. And that carbon dioxide is not going anywhere. It stays in the atmosphere and its heating effect continues. So we need to reduce the amount that we're pouring into the atmosphere, and we also need to remove carbon dioxide for two reasons. One is to get this number back to a safe level, so reduce the amount of carbon dioxide in the atmosphere. But secondly, to get to net zero, we can't eliminate carbon dioxide emissions. We can only reduce them. There'll be some that will be very hard to get rid of. So we need to remove the net carbon dioxide that we're putting in the air. So there's a kind of dual track here of reduce CO2 and remove CO2. Reducing CO2, obviously decreasing consumption, increasing efficiency. So things like on the consumption side, eating less meat, flying less will have a significant impact. Renewable energy, I'm not going to go into any details here, but just different renewable energy technologies to think about. And then carbon capture and storage. And I just want to make one point about carbon capture and storage, and actually a little bit about renewables as well. If you look at the CO2 footprint, this is data from 2011, so we can probably find something more recent. But if you look at the footprint of different forms of energy, CCS on gas, for example, approximately halves the emissions. It doesn't eliminate the CO2. So going from 400 to 600 down to sort of 160 to 220. And the renewable technologies, they're very good, but they still emit some carbon dioxide. So solar in particular emits a fair bit. So just worth remembering that. Then we look at removing CO2. So some of the techniques to think about, say perpetual forests, as in reforestation, but then keeping those forests there forever. Rewilding, change of land use, including ocean wetlands where there's significant possibility if we can change human behaviour to allow that. Soil carbon sequestration, very promising, very impactful solution. Bioenergy with carbon capture and storage is what's in all the models. There are some challenges with that we'll come on to. Direct air capture, so machines that just suck the air out of space, suck the carbon dioxide out of the air. Enhanced weathering, basically is accelerating systems that would take thousands of years to take CO2 out of the air, using rock and minerals to make it happen quicker, and then putting stuff in the oceans, which could be incredibly effective but also could be very environmentally damaging, so lots of questions to be asked there. There's another bunch of stuff, e.g. using building materials, using CO2 for fuels for greenhouses. This stuff is, it's great, let's do it, but it's going to be very, very small in terms of scale. So almost a rounding error there. For all these techniques, different things we need to think about. So first of all, cost obviously is going to be fundamental. What's the economics of doing this? In fact, the one above that is land impact. So how much land is this going to take up? What's the cost? What's the measurability? Can we actually measure how much impact the different actions are taking for sure? A really, really big one is permanency. So an example here is with forestation. Forests are predicted to take carbon dioxide out of the air for decades, whereas BECCS and direct air capture, where you're putting it underground, that will be for millennia. So there's going to be a big difference there. But the low permanency stuff is also useful. Then there's the social acceptability. Obviously, so planting trees, and very few people are going to be against that until it gets to a certain scale where it starts impacting our food supply chain. But some of the direct air capture technologies might be more questionable, for example. Does it need sequestration? So do you need capacity under the ground to store carbon dioxide permanently? The scalability is really, really key. And the speed of impact. So coming back to forestation, for example, the scale needed, I've heard anecdotally in the UK, if you were to do it intensively, very intensively, you'd need about the size of London to offset the UK's emissions. If you were to do it less intensively and more naturally, maybe, you might need the size of Wales. So a lot of land use needed. and starts to compete with agriculture and things like that. Whereas some of the direct air capture technologies, in theory, are much more scalable, and the land use is much less. Speed of impact is another really important one. So again, coming back to planting trees, there are question marks about, if we're talking about a decade, which we are, net zero by 2030, actually how much carbon will tree planting projects take out of the air by 2030? And I don't know how long they take to actually start to have that sort of impact. So just have a little thought and done a little bit of top of my head analysis. I'm not an academic. I've just learned quite a lot over the last 10 years, so I'm very happy to share this with the group. One last thing to say on sequestration, so carbon capture and storage, on the storage aspect. Yes, there's massive capacity, and if done well and done right, it can be stored for thousands of years with minimal leakage. So a few things there on carbon dioxide removal, and then I just borrowed my daughter's easel. A couple of things on systems change. So anyone looking at this, well, you have to look at this from a systems perspective. You have to think about how government, business and civil society will work together to make this happen. Really recommend reading The Water of Systems Change on fsg.org. And one of the key conclusions from this is nothing will change unless you can change mental models at scale, change the way people think and people behave. Just look at what's happened with ocean plastics. So 2 or 3 years ago, no one really cared about it, apart from the usual suspects and a small sector of society. But now it's mainstream, and you've actually changed the way people think and changed people's belief set. So you can change all these other things. You can change power dynamics, you can change practices, relationships and connections, but it won't stick unless you can find a way of changing mental models. The second thing to think about is if you look at the anatomy of a systems change here, it's really important to mobilize corporations. The Tagaytay Plastics Strategy Group came up with this wonderful phrase that corporations turn the tide, and they do. So it's rarely, corporations are rarely involved as the early agitators. Increasingly they are actually getting involved at that stage, but they're really bringing their muscle. But as soon as you start to think about how you scale change, then corporations are becoming really key players. And actually it's in their interest to do so, because the ones that lead change will be the ones that survive in the future. Thank you.